Okay, so as I was saying very intelligently, because they want to show G prime as a third, we can find the average rate of change of G and use MVT. And as Joyce and I forget who else has chimed in very correctly, the average rate of change of G on 0 to 3 is a third. You guys are so good. So that's -1 minus -2. Now, most of the time, they take it the whole interval. So if they ask you to show G prime equals a number, it's usually the average rate of change on the whole interval, which is what I was trying to do, but I messed up badly there on that last attempt. But either way, it's going to be this, and that is 1/3. So that's the average rate of change. Now all I got to do is explain why G prime has to equal that. So we're going to write, since G is differentiable, because it tells us that in the question, right? And we could have tied this all in together here, but I'm going to rewrite it. This equals a third. Boom. There must be at least one x value that says at least. Hey guys, don't worry about a timer. Turn that off. I see the time. You're working. Tell it to stop.
Stop timer.
Where G prime of x equals 1/3. Cool. So you want to state the conditions. Since G is differentiable and continuous, then you got to say that too. Okay. And the average rate of change is 1/3. There must be at least one x value where G prime of x equals a third. That's all. All right. So that's like an AB question. That's all. Hey, Luke, can you shut that door for me, please? Luke, can you shut that door for me? Yes, please. Thank you. Okay. Part B. So remember, what we learned to integrate this year was parts. We learned how to handle trig substitution, which I'd be surprised if they did that. They could do it because it's part of our curriculum, but I think they're going to go with parts or maybe partial fractions is what I usually see in terms of them checking your integration skills. Okay, and also U sub. Don't forget U sub is a thing here, but this is definitely parts because we have an x times some other function here. So we're going to have to let u be 40x, which means du is 40, which means dv is the third derivative of x, and that means v is the second derivative of x. And it's not above them or not like beyond reason that for them, instead of them giving you the third derivative of x like that, they might give you a third derivative of like 4x. And then when you integrate that, it's kind of like a u sub. You got to let u be 4x, and that would put a 1/4 out front here. Okay, now they're not doing that in this question, but I've seen that happen a lot. So be careful. If there's an inside function in your in f or whatever they have you integrating, just make sure you're doing a u sub to take care of that. But right now it's just that. So that means that integral is going to become, and I'm gonna move this over to give myself a smidge more room. Boom. Okay. So that makes this integral become v times u, which is 40x times f double prime of x, minus the integral of v du, which is 40 f double prime of x. And these are both still from 0 to 3, right? Like that. So this first part again is 40x times f double prime of x. When you integrate 40 f double prime of x, you just get 40 f prime of x. And that's the whole integral. And that is from 0 to 3. Which means when we plug in 3, we get 120 f double prime of 3 minus 40 f prime of 3. That's the 3 we're plugging in. Minus, we got to plug in the 0. But then that becomes 0 minus 40 f prime of 0. And that's our answer. We just got to find out what these dumb things are. And we're going to find them because they tell us way back over here. If you got any questions, guys, just chime in for a second. They tell me what f is. It's right here. So I need to know what f prime is and what f double prime is, okay? So let me steal that just so I can drop this over here too. All right, so we're missing, again, f double prime and f prime. So just based off what they're telling me, this y is not really here. Don't worry about that. F prime, remember how to derive an integral? The 2 goes away, right? If that was 2x or something, you'd have to derive and get a 2, but a 2 just derives away. The plus sign separates them, so we can look at them separately. So 2 derives away, and the derivative of an integral is the inside function with the top limit plugged in times the derivative of what you plugged in minus the same function with the lower limit plugged in times the derivative of what you plugged in. So that goes away completely, and that's f prime, which means f double prime of x, which we also need, is g prime of 3x times another 3, which makes it a 9 there. And we need to know what's f double prime of 3, and what's f prime of 3, and what's f prime of 0. So f double prime of 3 is going to be 9g prime of 9, which they gave us way over here. G prime of 9 is 3/4. Cool. So times 9 is 27/4. Cool. So that's f double prime of 3. So we have 120 times 27/4. So we can reduce that if we want. I'm not going to worry about it. Minus 40 times f prime of 3. Well, that would be, just from over here, f prime of 3 is just 3 g of 9. And from our table, g of 9 is negative 1/20. So just make sure you take it from the right columns, which I was not doing there initially. Okay, and then we have 0 minus 40 times f prime of 0, but f prime of 0 is 3g of 0. And g of 0, they told us, is negative 2. So it's negative 40 multiplied by negative 2. And we can leave the answer just like that. We don't have to get too crazy about this. And around the AP test, I definitely would. You're not going to have a ton of time. Don't worry about simplifying this stuff. You have a calculator if you want to use it, but this is a totally fine way to leave that. Just remember, if there are units on this question, write out your units. Okay? Just like put them here, like units right there. Bam. All right, so that's that. So use a right Riemann sum to approximate the length of the curve. So remember, the length of a curve is 0 to 9, the square root of 1 plus the derivative squared. Okay, and that's, so we have two ways that, well, actually one way is parametric. So parametric's not going to be on this test at all this year. So the only arc length formula you need to remember is that square root of 1 plus g prime squared. And if you remember, that was just the Pythagorean theorem really on an infinitely tiny interval added up. So we want to go 3 subintervals, and we want to go 0 to 9, and we need g prime. So this is going to be kind of a pain in the butt, but we're going to have this subinterval, and this subinterval. So this is approximately equal to my first, we got to write this out here. We're doing a right-hand sum, right? So our first rectangle is from 0 to 3. So I'm gonna move this out a little bit here too. You go up here. Okay. So we have a base of 3 and a height. Here's the problem. It's a right-hand sum. And I don't think they'll do this to you on the AP test, like make you use a table to plug into another function. But g prime on that right-hand side is root 8. But that's not the height of the function because I'm not integrating g prime. I'm integrating this square root of 1 plus g prime. So I have to plug that root 8 into this function here, and that's going to give me root 8 squared is 8 plus 1 is 9, and the square root of 9 is 3. So that's what that is. If you don't see that, let me know what's going on there. But again, we're just plugging in root 8 for g prime. My next subinterval has a base of 2, and the height of the function I'm integrating, which again is the square root of 1 plus g prime squared, we're going to take on the right-hand side of that interval, that's the root 3. So it's 1 plus root 3 squared, which is 3. That's a 4, root 4 is 2. Plus, my next interval has a width of 4, because we're going from 5 to 9, right? And we're taking the height on the right-hand side of that, which is 3/4, but plugged into this function. So 3/4 squared is 9/16. But that makes this one a 16/16. So at least they made these numbers nice. That makes that 25/16. And the square root of that is 5/4. Okay, and again, you can leave it just like that. This is not hard to add up, but we can leave it just like that, and that's all they want you to do. Okay, you might see if they ask, is it like an overestimate or underestimate? Remember, with right-hand sums and left-hand sums, it matters if the function's increasing or decreasing. They're not going that route here because this is they can't ask that question right now, but they could. Remember, for trapezoid rule, over and underestimates have to do with the concavity of what you've integrated. So we want the second degree Taylor polynomial for f. And remember, all that means is we need to find f of 0, f prime of 0, and f double prime of 0. That's it. And then we plug them all into our little formula for a Taylor series. So we did this already, but we'll come back up. F of x, f of 0 is going to be 2. I hope you all see that. F of 0 is 2 plus the integral from 0 to 0 of g of t dt. That's just 2. And they have to do that because we can't integrate g because we just have a table for it. So f of 0 is 2. Boom. F prime of x, we wrote this before, I wrote it over here. F prime of x, the 2 goes away, was 3g of 3x for reasons I explained before. Okay, so f prime of 0 is 3g of 0, and g of 0 is negative 2. So 3 times negative 2 is negative 6. Okay, is that what we got over here? Why does that feel different? Why did I just get, should that number be a negative 6? Did you guys notice that? This should be a negative 6. Not well. Okay. Guys, I'm making little tiny errors and you're noticing. I don't know how many of y'all are paying attention over there. Please let me know. But f double prime of 0 is the derivative of f prime, right? So f double prime is 9 g of 3x, g prime of 3x. And g prime of 0, when you drop a 0 into that, you get g prime of 0, and that's 4, and you're multiplying that by 9, which is 36. So p sub 2 of x is just the constant term, that was 2, plus, well, minus in this case, our first derivative divided by 1 factorial, x to the first, plus our second derivative 0 divided by 2 factorial, x squared. What's up, big man?
I need help.
Need help with what? You gotta bring your laptop out here, dude. Okay? All right. And the last part of this question from our friend Brian Passwater, who I do not know, is a geometric series whose first 3 terms are defined by P2 of x. Find the sum of the series when x is 1/6. All right, so they're telling me this is, why does it say network not available? Did you turn the internet off?
No.
Seems suspect. Come on, Chromebook. There we go. So, oh no, we typed the password in already. Dude, there's a pad on the side of the fridge that has a little beagle on it. It's green. It's kind of up high. You got to grab it. Do you see it? Okay. So anyway, they're telling me this is geometric, so I'm going to rewrite p sub 2, so I can see it. So it's 2 negative 6x, thanks big guy, plus, that's 18x squared. So if it's geometric, it must mean we're multiplying by something. And as you can see, we're multiplying by a negative 3x each time, right? Because that 2 times negative 3x is 6x. 6x times negative 3x is going to give you that positive 18x squared. So r is negative 3x, and a is 2. Cool. And luckily for us, we know that a geometric series. So it says, this is weird, find the sum of the series. It doesn't say find just p of 2. That's just an approximation. It says find the sum of the series. And the sum of a geometric series is always the first term, 2 over 1 minus r, which in this case is negative 3x. So if they ask you to find a function for it, that's what it would be. All right, but they want to know what's happening when x is a sixth. So that's 2 over 1 plus, because the negatives combine, right? And 3 times 1/6 is a half. And you can leave it like that, but that's just 2 divided by 3/2, which is 4/3, right? All right. So that's that. We're going to do the next one in a second. Hang on, big guy. Let me just do this. So my password is, all right, let's type this in, period. 3 is the worst period. Enter. All right. Cool. Let's see if that works. Any questions? We feeling good? Oh no, I said my password to my Wi-Fi out loud. Now you guys can be stealing my super fast internet. I can't tell. Are there other questions? Are we good? No, just one thing. Kobe Middleton, very good at 9:15. Okay. Who's the guy with a big head? Let's look. Where? That's Maui, dude. From Moana. You're welcome. Dude, the internet's not working on your little tablet, dude. Let me just hit back. You don't tell me what to do.
I'm hitting back.
Okay, go ahead. We're going to do the second question of this test here. Are you guys alive over there? This is making sense? Why isn't this working? Sign into your Chromebook. What? We're having technical difficulties on my son. Buddy, I might have to do it. Sign in. Okay. Yes, that was a comment. People are here. Sam's here. Okay. Yo, yo, yo! Go sit on the sofa and do this. Don't drop that thing. All right. Here they're giving us a graph of f prime. Very sweet. They're telling us f of 3 is 7. The graph of f prime is shown. F prime from 1 to 6. Oh, it's a line segment. Okay. The function h not shown above is defined by 2x minus 5. G is this. Find g prime of 2. Great. So we got to do the product rule in the chain rule here, right? So g prime of x happens to be 2x f prime of x squared minus 1. That's a derivative of the first thing times h of 2x plus, leave the first function, x squared minus 1, f of x squared minus 1. Derive the second. That's 2h prime 2x. And we want to evaluate that at 2. So g prime at 2 is going to be 2 times 2 is 4. Then we need to know what's f prime of 3. Okay, because that's what this becomes right here, f prime of 3, when you drop a 2 into that. And because f prime is a line segment right there from 1 to 6, you can see it goes from this point to this point. No, you got to keep doing what you're doing, buddy. It looks like negative 2, right? Boom, boom, boom. Yep, negative 2. So f prime of 3 is negative 2. And then h of 4 is what we get when we plug a 2 into that. When you put a 4 into there, you get 2 times 2 is 2 times 4, is 8, minus 5 is 3. Whoa, 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 whoa. Take that in the other room there, Chief. Come on, Elliot. We're working here. No, go in the other room, big guy. Elliot, go in the other room. All right. Then we need f. You put it to of 3. And f of 3 is 2. That's this part right here. 2. Times that extra 2 and times h prime of 4. But h prime is just 2. Boom. So that's g prime of 2 right there. All right? Great. Given this is 22/3, finds f of negative 1. Oh, my. They're asking that, so we can tell, too, because you have to plug a 2 into this thing eventually, and h of 2 is negative 1. That's what's going on there. So, given that this equals that, okay, so they're making this look tricky. This is what I was talking about in the last question. We have an inside function, so we're going to have to do u sub, which looks kind of hard because we're going to have to let u equal that h of x, right? But we can really simplify this by just letting u equal what h is, which is that. Okay? So to integrate this, we need a 2 dx, which means you got to put 2 in there and a 1/2 out front. So this is going to become 1/2 f prime of u du. And the original integral is going from 2 to 4, but if x is 2, u is negative 1, and if x is 4, u is 3. Hey, shut that door, guys. Elliot. So it's going to be 1/2 times f of u from -1 to 3, which is 1/2 f of 3 minus f of -1. True. And we know what f of 3 is. It's 7. Guys, did I mess this up? I did right here. I said f of, I took that off that graph. Oh my God. Did you guys notice this? Why aren't you yelling at me? This is a graph of f prime already. Okay, I didn't mess up terribly. I'm not paying attention to what graph I'm looking at here. Okay, so this is an excellent lesson in me messing up. Good God. When we did g prime, everything was correct, but when I did f prime of 3, and if you noticed this and didn't tell me, shame on you, what I did was I found the derivative of this graph, which was -2. But this graph is f prime, so f prime of 3 is just 2. Okay, so this is just 2 here, not -2, which was the slope. Okay, that means when you plug 2 into this part right here, you get f of 3, which I said was 2, but that's not. That's the point on f prime. F of 3 is 7. Goodness gracious, 7. There you go. That's all. Anyway, this is 1/2. Down here, remember where we are. We integrated, we got to plug in, we got to find f of 3. That was 7 minus f of -1, which we don't know. That's what they asked us to find, but we know this integral has to equal 22/3. Okay? So that means that if we multiply by 2, we get 7 minus f of -1 is 44/3. If we subtract 7, we get negative f of -1 is, what's 7? 21/3. So it's going to be 23/3, right? And then divide by a -1. F of -1 is -23/3. There we go. Just double check I'm not messing this up. Goodness gracious. Rough morning here. 21 from this is definitely 23. Yes, over 3. Good. Okay. All right. So that's f of -1. All right. Again, let me go back here. Again, I don't know if I can't tell if you guys are there or not, or if you're shaking your head at me. So twice now on this test, I've taken the wrong values off because I wasn't paying attention to the function I was looking at. All right, so just keep that in mind when you're taking the test this year. Pay attention to what function they're giving you and what function they're asking about. All right. C is another thing with parts going on. So, and again, they're dropping h of x in there, but h of x is really just that 2x minus 5 function, right? Or 2x minus what? Yeah, 2x minus 5 function. So we're going to let u, we have to do parts, equal that 2x minus 5, and we're going to let du be 2 dx. Not let, it has to be that. dv then is f double prime of x dx, which means v is f prime of x. So that's going to turn this integral into u times v, which is 2x minus 5 times f prime of x, right? U times v minus v du, which is 2 times the integral of f prime of x dx. And the limits are still on there, 1 to 5, but let's just finish up this integral. So it's 2x minus 5 f prime of x minus 2, the integral of f prime is f of x. And we're going from 1 to 5. Okay. Have we found f of 1? We have to find f of 1. Okay. But we know f of 3 is 7, and we know f prime. Okay. And we can find f of 5 too. That's what they want us to do. All right. Let me erase all this junk over here. Okay. I promise I know what I'm doing. I'm a professional. All right, we're going to plug in 5, and that's going to give us 10 minus 5 is 5 times f prime of 5 minus 2 f of 5 minus. We got to plug in 1. When you plug in 1, you get 2 minus 5, that's negative 3 times f prime of 1 minus 2f of 1. And unless I'm missing something here, we got to find f of 5 Yeah, and f of 1. Like we know f prime of 5 because we have the graph of f prime. So f prime of 5 is right here. It's -2. So let's fill in what we know so far. This is 5 times -2 minus 2f of 5, which we're going to find. Don't worry about that. Okay. Minus -3 times f prime of 1, and f prime of 1 is 6. That's right here. Okay. So it's -3 times 6. That's -18 minus 2 f of 1. So we're missing f5 and f of 1, and the only reason why we can find them is because I have f prime, and f prime is just a line. Okay, so on this interval right here, because this is just a line, f prime of x is just -2. No, that's -2x. What is that, a 4? So we plug a 4 in there, plus 8. That's what f prime of x is. Okay, everybody see that? Like that's, so f prime, again, just that's only from 1 to 6. Cool. But that's here to here. That's that line, -2x plus 8, which means f of x has to be -x squared plus 8x plus c. All right, but we know that when you plug in 3 to f, you have to get 7. So that will be -9 plus 24, which is what, 15? So c would have to be -8. All right. You could also set this up, by the way, too, that f of x equals, remember this, 7 plus the integral from 3 to x of f prime of x dx. And you can put what f prime is in there and do that way too. And you have a calculator, so that'll work out if it was a harder function. But we got to do this. And what do we need? F of 1 and f of 5. So f of 1 is, what's that? -1 minus 8, -9 plus 8 is -1. And f of 5 is -25 plus 40. It's at 15 minus 8, 7. That makes sense. It makes sense that f of 5 is 7 because f of 3 is 7. Or f prime is, f of 3 is 7, and f prime is here. And look, we have this area here, which represents an increase, and then this area here, which represents a decrease. So it goes up and down the same amount. So f5 is 7, f of 1 is -1. Yeah, we don't need this parenthesis here. Okay, so this is 7. This is -10. Oh my. Minus, this is -18. And f of 1 was -1, we said. There we go. We could also find the area under that graph, but we can simplify that out. But that's what that answer is going to be there. So that's kind of an extra stretch there to find those values. I think the AP test would set you up a little bit easier in finding those. All right. I know we're running out of time here. From 1 to 2, I don't know if they want us to find what man, I guess they do. So this is partial fractions, and you can tell because like you can't integrate that stuff with that stuff down the denominator like that, okay? But from 1 to 2, like we said, f prime is just that line, -2x plus 8. So we're going to have to do that here for this part. And I think that's, again, another little extra step that they wouldn't do to you. Like they would tell you this. They'd make this more explicit that this is what they wanted you to do. But h of x is what, that 2x minus 5? And this is exactly partial fractions. This is what we're going to have to do here. Okay, so the first thing I would do, just to make this easier for myself, is, I'm going to come down here, but I would pull a -2 out of this factor right here. Okay, and I take that 6 out front. So that's going to make this happen out there. So up top, we just have x. Down the bottom, this is going to be an x minus 4. And this is going to be a 2x minus 5 dx. All right, and we got to do partial fractions here. So this becomes -3, the integral from 1 to 2. They want us to do the whole thing? Yes. And we're going to have something over x minus 4 and something over 2x minus 5. And they're both linear, so they just get one letter on top, which means all we got to do is put this back together here real quick. And you get a 2x minus 5 plus bx minus 4. Woo-hoo. And that's got to be the numerator that was there originally, which is x. So when you drop a 4 into there, you get 3a has to equal 4. That makes the b term go away. So a is going to be 3/4. Nope, 4/3. Come on now. And when you drop a 5/2 into there, that takes this whole term away. So we're left with 5/2 minus 4, which is what, 8/2, so it's negative 3/2. So negative 3/2 b equals 5/2. So when you multiply that by a 2, that goes away to 5 and divided by negative 3. So b is negative 5/3. Okay? So the integral is going to be easy. It's the integral from 1 to 2 of 4/3 x minus 4 plus negative 5/3. And you can make that minus if you want. 2x minus 5 dx. And they're just going to be natural logs, right? So this becomes negative 3. Actually, so negative 3 out front, we might as well multiply back in here and make this a little bit simpler. Okay, you don't have to, but negative 3 times 4/3 is just negative 4. And negative 3 times negative 5/3 is just 5. So that we didn't have, I split that up because I thought it'd be easier. If we left a 6 in there, it would have been a little bit nicer numbers. Okay, but this becomes negative 4 natural log absolute value x minus 4 plus, and here's something a lot of kids miss easily. It's ln of 2x minus 5 here, but you got to divide by a 2 out front because the derivative of your denominator is 2. Okay, and that's from 1 to 2, and now all you do is plug in, which is a little bit nicer. So that's going to be negative 4 ln of 2 plus 5/2 ln of, plug 2 in there, you get 4 minus 1, so 1. So that's just a 0, that just goes away. Minus, when you plug a 1 in, you get negative 4 ln of 3. Remember, it's negative 3, but it's an absolute value. Plus 5/2 ln of, you put a 1 in there, you also get negative 3, so 3. And we just leave it like that. Yeah, this turns into a 0. We can simplify that some, but again, free response, you don't have to. All right. Last thing. A third degree Taylor polynomial for k. Let me snag this down here. Again, we've seen questions like this before. Like, they're going to make it weird for you to do this, but let me come up. Let's go over here. To find a third degree Taylor polynomial, what we need, so they gave us k of 1, we're done. We need k prime of 1, which they told us is right here. So that's just, okay, chill. Great. So k of 1 is negative 1. K prime of 1 is just f of 3, which they told us was 7, right? K double prime of x is, which is f prime. That's easy. It's just f prime of x plus 2. So k double prime of 1 is just f prime of 3, which we said was that line. Oh no, we had to find that, right? That was 2, I believe. Right, because they gave us a graph. Yeah. So f prime of 3 is 2. And we're also going to need f double prime of 3, and that's just the slope of this line, which was negative 2. So that's that. And then k triple prime of x is f double prime of x plus 2. So k triple prime of 1, that's a k, is f triple prime of 3, no, double prime of 3, which is the slope of f prime at 3, which we said before was negative 2, and I messed up. So we've got all the values we need. So a third degree Taylor polynomial, which we'll call p sub 3 of x, is the y value plus the first derivative divided by 1 factorial x minus 1, plus the second derivative, which was 2, boom, divided by 2 factorial times x minus 1 squared, plus the third derivative, which is negative 2, so minus 2 over 3 factorial x minus 1 cubed. All right, that was an adventure. All right. So let me stop this.